Welcome, everybody, to another episode of Practical AI. Today, we're going to talk about training. Peter's going to help us out a little bit. My name's Jeff. This is Peter Lynn. Be sure to subscribe. That way, you'll get access to any sort of updated videos that we do, new videos. We've got a little bit of a series going here. Also, a bit of advice. I've been told by our producer that both Peter and I talk very, very slowly. So it might be in your best interest to jack it up to 1.5 or even 2 times. I watched our last episode in 1.5 times, and it was pretty good. So with that, Peter, why don't you introduce us to the idea of training?
Okay. So broadly speaking, we talk about training AI and training models. At the highest level, we can group into 3 different kinds. So there's supervised learning, there's unsupervised, and there's semi-supervised. So today we're just going to cover the simplest one, which is supervised, but I'll give a quick description of all 3 just at the start. So supervised means that a human being will go through, get data, and then they'll add hints. So for example, if we're getting pictures of dogs, cats, elephants, and birds, we'll take the pictures and we'll label it dogs, cats, elephants, and birds. And this way, when we feed it to the model, when it goes through and it predicts, it can say, okay, we think this is a cat. And then it'll check, okay, what's the truth? What's the label? Well, it's an elephant. So if it said it was a cat, then obviously it's wrong because the actual label is elephant. Unsupervised means that we just give it data and we don't tell it what the labels are. We just say, here's data. Try to learn something from it. And so far, the research shows that purely unsupervised learning for images and for music and audio and stuff like that really doesn't work because it doesn't know what the ground truth is. In other words, it doesn't know what's important to a human being. Now that varies then when we get to things like language models. And then semi-supervised means that we will label some of the data. Once it gets to a certain threshold, let's say we say when it gets to 70%, we can then have it supervise itself. And so then we train it to 70%, and then we can then have the model itself take new images and try to label it and then use that for additional training. So that's broadly speaking the 3 different ways of training models.
So essentially, with the supervised learning, you're giving it the answers to the test.
Yeah.
In the unsupervised, it's kind of like going to a foreign planet or something, for the algorithm or let's say I went to a foreign planet and I'm seeing all these new things. I wouldn't know what to label them or what they are either, right? So to have some sort of source of truth helps whatever's trying to learn in the supervised learning get to the end quicker. So so before we jump into supervised learning, do people still do unsupervised learning at all in machine learning, apart from the hybrid later?
So there is a small percentage of the researchers are still exploring unsupervised learning. But a few years back, there was a paper that kind of provided a proof that unsupervised learning, by and large, doesn't work. The caveat is with language models. So in the old days, when we trained language models, we actually had a human being go in and say, here's a sentence, here's the subject, here's the object, here's the prepositional phrases, here's the verbs, the adjectives. So basically you would go through and you would tell it all the parts of the sentence. So that was the old way. The downside is it's very intensive. You need someone that can go through and correctly label all the parts of a sentence. The new way, which is with transformers like GPT, is we give it sentences and we randomly remove words and then we ask it to predict what those words are. And the nice thing is this actually means that we don't have to go in and label a sentence. We don't have to tell that this is the noun, this is the adjective, this is the subject, this is the object. It'll actually figure out English grammar on its own, just by this simple thing of removing words and then asking it to predict the word. And so that way, language models trained this way is really low cost in terms of human input, because now you don't need an army of people that are English majors to go through and label millions and billions of sentences, because that would take you years, if not hundreds of years, to go through and do that. So
Okay, so back at the ranch with supervised learning then, what's the process to train? And how does training work in the supervised space?
So the supervised space, I think the simplest one. For example, when you use like Google's photos or any of their like image stuff, what they have is they have a database of billions of images from Google Photos where people have tagged it, right? Because like when anyone takes a picture with their Android phone and they say, at the beach playing volleyball with Bob and Mike. Well, so now you've told Google, okay, it's at the beach, you're playing volleyball, and there's two people in the picture. And what they do is they write programs that will then take your descriptions and convert those into annotations. And then they can take that and feed it to their system to train a model that then recognizes kind of the common things that people take pictures of with their phones.
So would that particular image, be subset into a training data set that is specifically around beaches or volleyball or men or something? Or when people are training, are they using all the data on the earth? And that might be totally irrelevant if you're trying to figure out a pecan versus a pineapple, and it sees this image of people playing volleyball on the beach.
Right. So what a Google developer does is they have access to that and they can query the whole entire database of photos that people upload. Right. So let's say you're doing research on training a model to recognize stuff at the beach. You could do a query based on kind of keywords like beach, ocean, water, volleyball. You can come up with a list of words that you want to search on, and then it'll return you all the photos that people have tagged with that information. And
You
so
have
they,
to then do some level of curating of that data to make sure that you didn't end up with,
yep, you do.
sand or something, right?
Yep. 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 So that's part of the challenge. So that's what a data scientist does is they'll go through and they'll comb through the data, right? So if you think about Google Photos, I mean, they probably have over 100 billion photos because they've been collecting photos from users for more than 10 years. And I mean, like, I don't keep track of how much photos they have in their app, but that's a lot.
Okay, so you've for somehow you've got a data set of images. Then how do you use that to train? What's actually happening there?
Yeah. So the simplest way is, so I'm a Google engineer. I go up to photos and I query for, I'll say, give me 10,000 photos of the beach with these words in it. So I'll do that. And then what I'll do is I'll just divide it up into folders. So like maybe one folder is surfing. Second folder might be volleyball. Third folder might be barbecue. So I'll have a folder with a bunch of subfolders with the different topics that I want. So surfing, barbecue, volleyball, beach towel, whatever. And then when I train it, I point the model to this folder. It then reads the stuff, it reads the images, and it knows because it's in that folder called volleyball. And then the program is able to figure out, okay, everything under this folder is a beach volleyball related thing. And it goes through and trains it. So typically you do a small experiment on a couple thousand to maybe 10,000 or 20,000 photos. You'll do a test. You'll see, okay, how does my model work against it? So you run it for a number of iterations, which are called epochs. So epoch is you've got a data set and you go through the whole entire data set once. That's one epoch. But in practice, when you take a picture with the Android phone, those are like 4 or 5 or 10 megapixels. So those files are pretty big, and you can't actually load all of it. So if, let's say you have 10,000 photos and they're all 5 megapixel, well, that's like a couple of gigabytes of data. So you can't actually load all of it at once. So what we do is we break it up into small chunks, and then we load small batches at a time.
And what's actually happening? So the one epoch, one run of this data through the model, it's learning, right? Or it's trying, I guess is maybe the way I think of it. It's trying to figure out what is what. And then after the first epoch or the first run, what does the engineer have? And then how do things change for the next run and the next run and the next run? And how many runs do they do? And what's happening in that epoch?
Yeah, so typically you for a real training, you'll train for several thousand epochs. And typically what happens is, so let's say we take a picture of a volleyball. So you load the volleyball picture, you feed it to the model, and what it does is it takes it, converts it to a bunch of numbers, feeds it through, and at the end it says, oh, this was a beach towel. Well, no, it's a volleyball. So he goes, okay, how far off was I from the actual label? And then it goes backwards and it makes little changes to all these little weights on each layer. And then it takes the next image and it feeds it through. So let's say the next one is surfing. And it says, no, this is the beach volleyball. It's like, well, no, it's surfing. So it goes back again and adjusts all these weights. So it does this for the whole entire set of data. But at the end, it might have gotten better for surfing, but gotten worse for beach towels and volleyballs. And so this is why when you train, you run it for hundreds or even thousands of iterations, epochs, so that it gets better and better and better each time it corrects the weights, so that it gets better at recognizing all these different categories that you've identified.
So you can, maybe this is a dumb question, but you can have a single model do multiple things like surfing, volleyball, whatever, within the same model, or do you need a separate model for each of those?
So you can have a small model that does just a few things, or you can have a big model that does a lot of different things.
Okay.
The current trend today is to have a big model that does upwards of 100 to 1,000 different classes. And obviously that's kind of small compared to a human. Like humans can identify a variety of things and it's pretty much limitless. Whereas with these models, you define at the start, okay, here are the things I want to be able to differentiate. So if I'm building a grocery store model, I would go through and say, okay, well, there's lettuce, there's fruits, there's cold cuts, there's there's meats, there's cereals. So you would go through and define all the different classes that you want, and then you would collect all the pictures that you want, organize them into folders, and then you would train it. But the downside is if someone comes up with a new cereal, but it's not in a box, it's in a tube. Well, now there's a problem because is it oatmeal or is it cereal? Well, oatmeal is kind of a cereal, it's a hot cereal, but it's not like cornflakes. Right. And so one of the challenges for a data scientist is how do you collect a set of data that represents what will be seen in the real world? Meaning when a person goes to the grocery store to buy stuff, is it going to match? Right. And so if we train a model for the US, we have a certain kind of packaging. But if we go to, let's say, England, or if we go to Germany, their packaging is different. And so now if I take my model from the US and I go to Germany, well, it's probably not going to work because they have different packaging and different things.
One more question. So you kind of described that within the epoch, within one run, the model is kind of doing work against the data and kind of readjusting all the time until it kind of finishes with the data. And it, let's just say after the first run, it comes out as 18% accurate or something like that, or smaller or greater, whatever. What is either the engineer or the system doing to change the results of epoch number 2?
So that's the thing that's kind of it's literally just changing these little values, these little weights, which we'll call parameters. Because all the model does is it takes the data you give it and multiplies it by these numbers and it adds it up. And then it goes to the next layer and does the same thing and multiplies and it adds and it multiplies and it adds. So it's just doing billions of math operations. When you say predict what this image is, it's literally going through and doing like a billion calculations to give you a prediction.
Are you using for epoch number 2, or are you using like the best version of, at some point in epoch 1 it was doing really, really well and then it got bad? Are you at least starting on the epoch 2 with a better starting point?
Not necessarily.
Not necessarily.
Really, no.
So why would epoch 2 be any different than epoch 1? Why
So
wouldn't it just
so typically that's why people train it for thousands of iterations. The hope is that eventually, as it's training, it's going to go up and down. And after a certain point, it's such a level off, right? So like the accuracy starts to go up and down, then hopefully at some point it levels off around 70 or 90% accuracy. But that's not guaranteed. Oftentimes it just keeps jumping back and forth and it never stabilizes. So when that happens, you know, okay, well, the initial set of weights was not good. And so you just start a new run and then you hope that the next run works better.
But you're not as an engineer, you don't have any input on how to make that next epoch better, or the starting weights, or
not really. No, you take your data, you feed it in, and you say train, and then it magically tries to correct itself.
So the epochs don't necessarily get better over time.
They generally do.
Why?
Just because if you give it a lot of data, it'll statistically figure out what the averages are.
So is it learning from prior epochs?
Well, so every time you make a change to these weights, it in theory is getting closer to the optimal value that it should be at.
Okay.
In theory.
Well, there's a lot here on training, I know. Just trying to stay as high level as possible. There's a lot of the details are in the weeds, right?
Yep.
But this is a good start. Good discussion, Peter. Thank you. We've got great material linked below. So several good YouTube videos that run through great examples, and also a really good explanation of kind of explaining it at multiple different levels to really, really newbies all the way up to advanced machine learning experts. So really appreciate everybody joining us for this discussion. Like I said, subscribe, and we'll see you next time.